Okay guys, so let's continue talking about receptors, and we're going to finish off with the third main type, which is voltage-gated channels. So as I sort of mentioned in the previous video, we have kind of ion channels which can act as receptors responding to either ligands, which are just molecules, or responding to voltage. And obviously when we're talking about changes in voltages and movement of ions, this becomes super important when thinking about things like action potentials and nerves. So this is something that you'll become very familiar with. But it's the same sort of concept as your ligand-gated ion channels, except here the actual stimulant is a change in voltage or a particular voltage. So if we think about the initiation of an action potential, the first thing that we're going to do is depolarize the cell. And so to depolarize, you're going to make the membrane potential more positive. And remember, we measure membrane potential as the voltage inside compared to the voltage outside. So if it's becoming more positive, that means that the inside of the cell is becoming more positive. And so one way in which this can happen is if we move positive ions into the cell. And so this actually uses voltage-gated ion channels. So we have at a particular voltage some sort of initiation, some sort of stimulus, and at a sort of particular voltage, that's going to cause these voltage-gated ion channels to become active. And so you'll get movement of positive ions, in this case sodium, into the cell. That's going to make it more positive, and therefore the cell is going to begin to depolarize. And then obviously if we get above threshold potential, that means that we're going to get a full sort of action potential, which is obviously quite important to understand. And also, you know, this is a sort of general concept, so there are many different ions that could be moving here. And similarly, there will be some voltage-gated ion channels that respond to kind of higher membrane potentials. So once we get depolarization, obviously we need to then get repolarization. And one of the ways this kind of happens is the opening of sort of other ion channels, which then cause the membrane potential to become more negative and therefore return the resting membrane potential. So, you know, return our membrane potential back to sort of where it normally rests at, which is usually about -70 for nerves. So there are some kind of key concepts. So again, it's an ion channel, so it has some sort of central pore that ions are going to move through. There are lots of different ions that can kind of move through them. So key ones there are sort of sodium, potassium, chloride, and calcium. In terms of kind of voltage and charge and these kind of physics concepts, essentially these ions are going to open and close in response to certain voltages. And that's obviously quite important to sort of compare and contrast to the other receptor types. And then they're going to open and close. And as you can see on the previous diagram, there's normally some sort of structure which physically blocks ions from moving into them. And that's really quite important to sort of visualize, because that can help you to sort of understand how these ion channels actually work. So again, here's a sort of summary of how these work for your sort of revision. So if you want to kind of take these and use them as your kind of revision steps for your flashcards or whatever, and sort of draw diagrams, we've got that information for you here. So in terms of a specific example, I've already kind of alluded to this, but we have voltage-gated sodium channels, which are really important for depolarization in terms of action potentials. So, you know, you have these sodium channels kind of on the membrane of our nerves. And so essentially we're going to get some sort of conformational change, so a structural change in response to a change in voltage. And that's then going to lead to this ion channel opening. And therefore sodium channels are going to be able to move inside the cell. The cell then becomes more positive inside relative to the outside, and therefore we're going to get depolarization, and therefore the formation of an action potential, assuming the stimulus is strong enough to get over our threshold potential. And so this is going to occur all the way along the nerve, and then it's going to reach a synapse where we obviously get our sort of synaptic transmission. And so if this nerve happens to be a nerve leading to the neuromuscular junction, then we're going to get a different type of receptor on the actual synapse, which is what I talked about in the previous video, which will be our ligand-gated ion channel. In this case, it'll be a nicotinic acetylcholine receptor, which is going to be sort of active here. So that sort of concludes the receptor types. As I said, there is another receptor type called tyrosine kinase receptors, but that's sort of a little bit out of the scope at the moment. That tends to be more involved in things like sort of cancer and that sort of thing. But these are the kind of basic receptor types. And it's really important to know how each of them work, some key examples of where they're found, and also, be able to sort of compare and contrast them, as that can very easily be an essay question, for example. But I hope you found this useful, and I'll catch you on the next video, which I believe is a very short sort of quiz testing you on these receptor types. So thank you.